Hello everyone. In this video, we will go over two of the main concepts from Chapter 4 of FIN300, which is on the time value of money. These concepts being annuities and perpetuities. By the end of this video, you'll be able to identify whether questions an ordinary annuity, an ordinary perpetuity, a growing annuity, or a growing perpetuity, as well as know how to solve them. Before we jump into the main topics of the video, let's do a quick recap of some of the things we need to know beforehand. The time value of money tells us that money today will not have the same value at a future point in time due to interest rates. For example, $100 today would not equal $100 in 3 years. The future value is the value of a cash flow that has moved forward in time. For example, if we try to find out what the value of $100 after 3 years will be, we would be solving for the future value of $100. The present value is the opposite of future value. Present value is the value of a cash flow occurring in the future, expressed in terms of cash today. If we knew in 5 years we would receive $500, we can calculate what that $500 is actually worth today, and this would be called the present value. So let's start off with ordinary annuities. An ordinary annuity is a stream of equal cash flows occurring at regular intervals over a specified time period. The key thing to remember is that ordinary annuities have equal cash flows, which is bolded and also in blue, and they go on for a set time period, which is underlined and written in red. The underlined red is how we can differentiate annuities from perpetuities, and the bolded blue is how we can differentiate ordinary annuities from growing annuities. This differentiation will make more sense as we progress through the video. There are two methods to solve for the present value of an ordinary annuity. The first is with the formula method written on the left. This formula says that the present value in year 0 is equal to the cash flow in year 0 plus the cash flow in year 1 divided by 1 plus the interest rate. The denominator is to the exponent of the time period. So this 1 plus r is to the power 1 because this cash flow occurs in period 1. This pattern continues on for as many time periods as there are given in the question. Keep in mind that you may not always be given a cash flow in year 0, and usually the first cash flow will begin in year 1. So you won't always have this part of the formula where you have C0. This formula also always gives you the present value 1 period before the first cash flow. For example, if the first cash flow happens in year 5, this formula will give you the present value in year 4 and not year 0. The second method is using the financial calculator method on the right. This is generally quicker. However, the calculator only works if each period has the same interest rate. If each period has a different interest rate, you'll have to use a formula on the left. When using the financial calculator, N is our number of periods, I is interest rate given in the question written as a percentage, PV is a present value, PMT is a recurring cash flow, FV is a future value, PY is the number of payments per year, and CY is the number of compounding periods per year. Keep in mind that if you're using the formula method, you want to input your interest rate as a decimal. If you're using the financial calculator, you want to input your interest rate as a percentage. Now let's try an example. This is problem 4-9 from the Fundamentals of Corporate Finance 3rd Canadian Edition textbook. Suppose you receive $100 at the end of each year for the next 3 years. If the interest rate is 8%, what is the present value of these cash flows? If we drew a timeline for this question to visualize what's happening, it will look like this. We know this question is an ordinary annuity because there are equal cash flows in each period, which is $100 at the end of the year written below the timeline in blue. It also has a specified time period of 3 years, which can be seen above the timeline written in green. Go ahead and pause the video now and try to solve these questions using your preferred method below. So if you use the financial calculator method on the left, your input should look like this. Our N is 3 since there are 3 periods. Our interest rate is 8%. The present value we don't know, that's what we're solving for. The PMT is a recurring payment, which is $100 in this case. And there's no mention of a future value in this question, so we can leave that as 0. We can leave payments per year and compounding periods per year as 1, because everything in this question was given in terms of annual. This gives us a present value of $257.71. We can also use a formula method on the right, and we would get the same answer. Because the first cash flow is in year 1, This formula gives us the present value in year 0, meaning today, which is what we want. Also keep in mind that because there's no payment today, our C0 variable equals 0. The present value of $257.71 means that this is the value today of these 3 payments of $100, assuming an 8% interest rate. Now let's take a look at perpetuities. An ordinary perpetuity is a stream of equal cash flows that occur at regular intervals and last forever. The key thing to remember is that ordinary perpetuities have equal cash flows, which is bolded and written in blue, and they go on forever, which is underlined and written in red. The underlined red text is how I can differentiate perpetuities from annuities, and the bolded blue text is how I can differentiate ordinary perpetuities from growing perpetuities. Just like with ordinary annuities, where we can use the financial calculator to solve them, we cannot use the financial calculator to solve for perpetuities. This is because they last forever, meaning our n would have to be infinity, but we cannot enter infinity into a financial calculator. This means the only way to solve for the present value of a perpetuity is using the formula written here. This formula says the present value in year 0 is equal to the cash flow in year 1 divided by the interest rate. Just like with ordinary annuities, this formula always gives you the present value 1 period before the first cash flow. For example, if the first cash flow happens in year 5, this formula will give you the present value in year 4 and not year 0. Keep in mind that it's not possible to find the future value of a perpetuity because the cash flows never end. Let's try this example. This is problem 4-12 from the Fundamentals of Corporate Finance textbook. You want to endow a scholarship that will pay $10,000 per year forever, starting 1 year from now. If the school's endowment discount rate is 7%, what amount must you donate today to endow the scholarship? If we do a timeline for this question to visualize what is happening, it would look like this. We know this question is an ordinary perpetuity because there are equal cash flows in each period, which is $10,000 at the end of the year, written underneath the timeline in blue. The payments also go on forever, which is why timeline goes on until the year infinity, which can be seen above the timeline in green. Go ahead and pause the video now and try to solve this question using the formula below. Okay, so because this is a perpetuity, we cannot use a financial calculator and instead must use the formula written above. If we plug in our values from our question, we have a cash flow in year 1 of $10,000. We can divide that by the interest rate, which is 7%. Keep in mind that you must write the interest rate as a decimal, or your calculation will be wrong. If you aren't sure what the interest rate is as a decimal, just divide the number by 100, which is what we did on the left. 7 divided by 100 is 0.07. So plugging that back into our formula, we get 10,000 divided by 0.07, and this gives us a present value of $142,000, $142,857.14. This answer means that if we want to pay out $10,000 per year forever, we would need to spend $142,857 today. The reason this works is because of that 7% interest rate. This prevents a lump sum from running out over time. Okay, now that we looked at ordinary annuities and perpetuities, let's take a look at growing annuities. A growing annuity is a stream of growing cash flows occurring at regular intervals over a specified time period. The difference between growing annuities and ordinary annuities is that with ordinary annuities, the cash flows are a fixed amount and do not change over time. With growing annuities, the cash flows will grow over time by a specified growth rate. Growing annuities have a fixed ending date and do not last forever like perpetuities. Unlike with ordinary annuities, where we can use a financial calculator to solve them, we cannot use a financial calculator to solve for growing annuities. This is because growing annuities will have a growth rate that is separate from an interest rate. Most financial calculators don't have a way to input a growth rate. This means the only way to solve for the present value of a growing annuity is using the formula written here. This formula says the present value in year 0 is equal to the cash flow in year 1 multiplied by 1 over the interest rate minus the growth rate, and that's multiplied by 1 minus 1 plus the growth rate divided by 1 plus the interest rate to the power n, where n is our number of periods. Just like with ordinary annuities and ordinary perpetuities, the formula always gives you the present value 1 period before the first cash flow. Now let's try an example. This is problem 4-43 from the textbook. A rich aunt has promised you $5,000 1 year from today. In addition, each year after that, she has promised you a payment that is 3% larger than the last payment. She will continue to show this generosity for 20 years, giving you a total of 20 payments. If the interest rate is 5%, what is her promise worth today? If we drew a timeline to visualize this question, we can see it's a growing annuity. Our first payment is in year 1, which is $5,000. The payment in year 2 is going to be 3% larger than the payment in year 1. This means that we can multiply the payment in year 1 by 1.03 to get the payment in year 2. We can multiply the payment in year 2 by 1.03 to get the payment in year 3. And this is because of that 3% growth rate. This pattern continues on until year 20. Go ahead and pause the video now and try to solve this question using the formula below. Okay, let's see how you did. C1 is the cash flow in year 1, which is $5,000. R is our interest rate, which in this case, it was 5% written as a decimal, so 0.05. G is our growth rate, which is 0.03. And then N is a number of periods. So in this case, we had 20 years or 20 periods because it was annual. So putting all that into the formula, we get our present value equals 5,000 times 1 divided by 0.05 minus 0.03 multiplied by 1 minus 1 plus 0.03 divided by 1 plus 0.05 to the power of 20. And this gives us a present value of $79,823.92. The final formula we will look at is finding the present value of a growing perpetuity. A growing perpetuity is a stream of growing cash flows that occur at regular intervals and last forever. With ordinary perpetuities, the cash flows are fixed and do not grow. You can also recall that annuities do not last forever and they have a set date at which they end. Just like with ordinary perpetuities, we cannot use a financial calculator to find the present value of growing perpetuities because they do not have a set number of periods and they last forever. This means to find the present value of a growing perpetuity, we can use the formula written here. This formula says the present value in year 0 is equal to the cash flow in year 1 divided by the interest rate minus the growth rate. Keep in mind that the interest rate and the growth rate both have to be written as decimals. Just like with ordinary perpetuities, the formula here always gives you the present value 1 period before the first cash flow. Another thing to keep in mind is that if the question says the cash flows decrease instead of increase over time, then our growth rate would be negative. Our denominator in that case would be R minus negative G instead of just R minus G. Let's try an example. This is problem 4-39 from the Fundamentals of Corporate Finance textbook. A rich relative have gifted you a growing perpetuity. The first payment will occur in a year. It will be $1,000. Each year after that, you will receive a payment that is 8% larger than the last payment. This pattern of payments go on forever. If the interest rate is 12% per year, what is today's value of the gift? If we drew a timeline to visualize the question, we can see that the years go on forever, which is above the timeline in green. The payment in year 1 is $1,000. We are told that each payment is 8% larger than the last payment. This means that we can multiply the payment in year 1 by 1.08 to get the payment in year 2. We can multiply the payment in year 2 by 1.08 to get the payment in year 3. This pattern continues on forever. Once again, go ahead and pause the video now and try to solve for the present value of this growing perpetuity using the formula written below. Okay, let's take a look at the solution. The cash flow in year 1 is $1,000. The interest rate is 12% written as a decimal, which is 0.12. Our growth rate is 8% written as a decimal, so 0.08. Plugging these values into the formula, we get our present value in year 0 is equal to 1,000 divided by 0.12 minus 0.08. This gives us a present value of $25,000. This grid summarizes how to identify whether a question is an ordinary annuity, ordinary perpetuity, growing annuity, or a growing perpetuity. If the question has a specified time period or gives you a value for n, you know to look at the specified time period row, which is the top red underlined row. Now, if there are constant cash flows, we know that it's an ordinary annuity. If the cash flows grow over time, we know it's a growing annuity. If the question does not have a specified time period or mentions that cash flows last forever, we can look at the bottom red underlined row. If the question says it is constant cash flows, we know that this is an ordinary perpetuity. If there are growing cash flows, this would be a growing perpetuity. Recall that out of these four, ordinary annuities are the only ones you can solve with the financial calculator. The other three you have to use their respective formulas. Hopefully you found this video helpful. Feel free to check out the Academic Success Center for course-specific tip sheets. Make sure you follow us on social media to stay up to date with our offerings. Thanks for tuning in.